Today we're going to be looking at solving some more complex equations. Now at this point I'm going to assume that you're starting to get quite confident with solving equations. If you're not, check out my early videos linked below. But for now, let's begin. Let's consider the following problem of 2 times everything inside those brackets of the x plus 3, and that is equal to 20. The first thing that we must do is to actually remove the brackets from our problem by expanding the left-hand side. To do that, I need to first go, what is 2 times x? And that's going to be equal to 2x. Then I go, what is 2 times positive 3? 2 times positive 3 is going to be positive 6, so we plus 6 to the left-hand side. And that is equal to 20. From here, we need to isolate our x value. To do this, we need to perform the inverse operations that we learnt in the previous video. So on the left-hand side, the first thing we need to remove is that plus 6. The inverse of adding 6 is to subtract 6, and that will cancel this out. However, whatever we do to one side of the equation, we must do to the other side. So we must subtract 6 to the right-hand side. On the left-hand side of the equation, we've just got our 2x remaining, and on the right-hand side of the equation, we've got 20 subtract 6, which is 14. Now we need to isolate our x value, and we've got 2 times x. The inverse of multiplication is division. So we need to divide this side by 2 to cancel it out. And to keep it balanced, we also have to divide the right-hand side by 2. Therefore, on the left-hand side, we've got x, which is equal to 7. Of course, we can check our answers by performing our check step with substitution. So if we substitute our x value back in, we'll get 2 times 7 plus 3, which is equal to 20. Of course, we've got to solve the brackets first. So this is going to be equal to 2 times 7 plus 3, which is 10. And that is equal to 20 still. Now 2 times 10 is equal to 20, which then balances our equation, and we've proven that our x value must equal 7. So to solve a problem with brackets, we've first got to remove the brackets by expanding them. Then we follow our normal process of isolating the x value. But let's take a look at a slightly more difficult problem. What if I've got 3 times everything inside my brackets of 2x subtract 4, and then all of that is divided by 6, and it equals 3. My first step is the same. I need to remove the brackets from my problem. To do that, I expand it by going 3 times 2x, which is equal to 6x. Then I go 3 times negative 4. 3 lots of negative 4 is negative 12, so I subtract 12. This is still all going to be divided by 6, and it's still equal to 3. Now we've removed the brackets from the problem, let's isolate that x value. To do that, I need to perform the inverse of what's going on that side. Now the last thing I would normally do is to divide by 6. The inverse of division is multiplication. So I need to multiply this whole side here by 6, which will cancel this out. However, whatever I do to one side of the equation to keep it balanced, I must do to the other side of the equation. So I must multiply the right-hand side by 6. When I do this, on the left-hand side, I'm left with 6x subtract 12 is equal to the right-hand side of 3 times 6, which is 18. From here, I now need to remove the subtract 12. The inverse of subtraction is addition, so I plus 12 to this side to cancel it out. On the right-hand side, to keep it balanced, I must also add 12. So on the left-hand side, I'm left with my 6x. On the right-hand side, I've got 18 plus 12, which is equal to 30. Finally, I need to isolate my x by performing the inverse of multiplication, which is division. So I need to divide my left-hand side by this 6 to cancel it out. But whatever I do to one side of the equation, I must do to the other. So I also divide the right-hand side by 6. On the left-hand side, I've isolated my x value. On the right-hand side, I've got 30 divided by 6, which is equal to 5. Therefore, I'm proposing my x value should equal 5. But of course, we can check to see if we're correct. So let's perform a check step. So we substitute our value of x into the equation. When we do that, we've got 3 times 2 lots of x, which is 5, subtract 4, all divided by 6, and that should equal 3. When we solve inside the brackets, we've got 2 times 5, which is 10, subtract the 4 still, all divided by 6, which is equal to 3. Next, we do the 10 subtract 4, which is equal to 6, should all divide by 6 and equal 3. 3 times 6 is 18, divided by 6 still should equal 3. 18 divided by 6 does equal 3, so what we've found is we've got the right solution, where x is equal to 5. So when you've got brackets in problems, it can be first helpful to expand the brackets. Then we follow the same process by isolating the x value on its own. So now it's your turn. I've got 4 practice problems in front of me that I would like for you to have a go at yourself.